Thank you very much for inviting me to speak over here. We've got quite a large project called Redmeadow, and I will present a few case studies of that one. But I will also give you a bit of an overview first to begin with on zero renovation for large buildings. What is it? With a focus on technologies that are integrated in the facade. So we have been speaking about simplicity with the building so far, but this over here you'll see we'll go the other way. I'm Florine Leighton, I've been introduced already from INTEC. I'll just point out that a colleague of mine is over here as well from the EU building, and I'll present some of his work as well. He doesn't know yet. So, thank you very much earlier. When all of these statistics were presented, I don't need to present them myself now, so I'll skip this. But I'd just like to mention that it's a motivator for us, of course, to reduce energy consumptions in buildings. So we've gone down the route of zero renovation. It can reduce energy. It's got a huge amount of potential, and it can also help in the transition of heat and energy. It's by no means the only solution that we've already seen, but it is one that we see quite a lot of potential in. So there are three questions I'd like to answer. One is, what is zero renovation? Secondly, how is it connected with heat and energy transition? And thirdly, what localized energy sources can we use? So here's the brief overview of zero renovation. So basically what we've got are panels that we mount to the outside of buildings, essentially giving them a new skin. Skin might be a bit thin. It essentially gives them a new outside wall, because these panels are fairly thick at the minute. We've brought them down to 30 centimeters, but other companies use 40. And these panels can hopefully more so in future just be more easily mounted using only a crane without scaffolding. That is key to reduce the time on the building site. There's a picture at the corner over there showing how the panels look like. So you've got several layers, but as you can see, it's got quite a lot of material. So that's also something that can be worked on in the future. Prefabrication of these panels is key to increase the quality of these panels, or the zero renovation method. You can shift all of the mounting and assembly, into a safe environment. It's like a stable environment. You don't have to do anything in the rain, and quality can be increased due to machines or whatever you might be using. One last point is it's got the possibility to include new technologies for heating. So I mentioned. Right, here's just an example from a different company. It's not my project, but it is an example of the, in inverted commas, simple way of zero renovation. I've taken this as an example from EcoWorks. It's been a building site in München. So this building over here that was, I believe, based on a gas heater. It's been given a new roof, photovoltaics on the roof, new facade with insulation, but no other technologies inside it. A ventilation system, okay, you can argue now, and a air source heat pump. The air source heat pump would be outside the building, nearby, but not integrated into the building. What we're proposing are some of these technologies directly in the facade, so they would be prefabricated in the factories beforehand. So what we're talking about are photovoltaics, solar thermals that can go into the facade, and we've got examples of them. Building activations, which I'll come to in more detail later on. Supply lines like pipes or so for bathrooms, if they were to be renovated at the same time. Controlled ventilation system, decentralized window ventilation, sensors, if necessary, decentralized heat pumps, intelligent shutters, and now I'm coming to the last one. It's not technologies, but it's greening. The possibility of adding something to the building to enable greening, not technology. there we go. So those are all of the options. But of course, sorry, going back to this, not one building will use all of these, obviously. You'll pick whichever technology is suited for the building, and you'll go with that. It might be two, maybe just one, maybe three. So here's an actual case study from our project at Renvelo. It's had this is how the building started. It had some insulation on it, but not very much, and the insulation was degrading. So that was one issue. There were quite high costs for heating. The other issue was that the roof was leaking. The air quality was in particular bad, and considering this is a school, air quality has got to be good. There are a couple of other issues, but essentially what we did was give it a new facade and a new roof. So up over here we've got the points that we've renovated, the key points. So new roof, glass roof, a heat recovery system with an air source heat pump, actually 3 in series, but it doesn't matter. Roof mounted photovoltaics, facade integrated photovoltaics, new facade with insulation, new windows with shutters automated, and facade integrated ventilation system. So you can see we've got quite a few technologies in there. We're now producing a huge amount of energy that we weren't before, so it's making it an active building. And I just want to note to the heat recovery system that we've got quite a, dare I say, quite a clever system, because we're using all of the heat produced in the school. We suck it out at the top. We use the heat recovery system. If needed, we'll use the heat pump systems, let the air dissipate, but the heat will go over the facade down towards the window where the decentralized ventilation systems are, and the heat then is used to pre-warm the air to go back into the classrooms. So you've got a cycle of the heat, but not of the air. And that was done. All of this renovation over here was done while the school was still in use. We're kind of proud of that singular point because it just shows that it can, you don't need to move everyone out of the building, you can renovate while they're there. And that is key for many building owners who rent out flats or so, just out of our idea. We've got another demonstrator of ours in Wien. They won't have to move the people out of their flats. I hope I'm getting time, but here's another one, another technology that we will implement into the 2 other demonstrators that we've got. We've got 3 in total, the first one I showed already. And over here we've got building activation. So it's essentially an underfloor heater that we have put vertically and we'll pop it up against the wall. So what we're doing, we're wrapping in a building in with the heating system, or with a underfloor heater. So we're heating the entirety of the building, which then means we've got an enormous amount of mass that we're heating, we're keeping stable. And that gives us a few advantages. The variation of the temperature is really, really slow, and we can pump in the heat when we've got it available. Coupled with a software, multiple predictive control, we've developed that at our institute, we will then be able to further optimize the use of the available energy. Yes, so that's all I wanted to say to this slide, I think. Next one is localized energy systems, what is available. I believe that I'd be sort of preaching to the choir if I was going to go into depth of all of these ones. Yeah, I think we're all quite familiar with the renewable energy systems. For one of the demonstrators in Wien, we're going to use ground source or geothermal, so ground source heat pump. For others, we've got air source heat pump, we've got photovoltaics. We're not going to use wind turbines anywhere or solar thermal. We do use heat exchangers. The point is, I guess, that every house will just pick one, maybe a combination of 2 heat sources. But your neighbour might pick a different kind of source, and that neighbour might those neighbours again might have different house setup, so might use a different heat system. And if you then think about communities, you would then have a pool of different energy sources which you could, if linked, but that's the big question mark, really, how to do that, if linked would give you a huge amount of advantages. So that's something we need to think about for in future. How do we link up these houses and the use of energies, because energy used on the spot is always better than in putting it in storage. Especially if you've got houses that have different usages, then of course the use of energy throughout the day will be more level. Right, my last slide. This is a study that the EBV has done for Envelope. We have identified that no-frills buildings are essentially the best kind of buildings for this type of renovation. So if you think about the buildings from the 70s, really quite boring facades, essentially, they're the best ones. And of course the ones that are run on fossil fuels. So in Austria alone, and I've got to say that these calculations were done with quite tight constraints. So we calculated, or the EBV has calculated, that 10,000 no-frills building would be suitable for renovation today, could be renovated without any further development, with zero renovation. It doesn't sound like very much, but if you think that we were to start very soon and to finish in 2050, then we'll have to complete one renovation per day. And I think that's a bit of food for thought. Thank you very much. This is a project.